Okay, now today we will start doing transmission line. I think recording is been done. Huh? Okay. So it will help others. Just listen. I hope all of you understood today's class about that plane waves reflection, normal incidence, how standing waves are created. A very interesting subject. Actually, we don't have time. And the major interesting topics is these two chapters, Unit 4 and Unit 5. Anyhow, just I'm trying to do the justice. Let's see. Time is not there. Transmission line. The idea is uh, transfer of power. What is transmission line? 1 second. Some is messaging. Okay, Bharat is messaging.
Yes, sir. The exam is on Thursday.
Okay, is on Thursday.
Yes, sir.
From Monday to Thursday is your CI or
From Tuesday, sir. Tuesday, Wednesday, Thursday. Yeah, sir.
so Monday can I get a one class? Okay, I don't know. If it is there, it is good. But no one will come. Another problem. Okay. Acha, listen everyone. What is transmission line? What I told, transfer of power. Transfer of power from one point to another. You can take this note also, or tomorrow I will provide another notes. Entire transmission line notes I will give. And it is very high quality notes. I am following Shibna Gaunkar, is actually IIT Madras professor. He was the director of IIIT Delhi also. So he used to teach this subject. It's really beautiful. You can also watch in NPTEL. You will get his lectures also. If you're interested, not now, after that one. Leave it. So transmission line means transfer of power from one point to another. How the power is being transferred from point A to point B. I think you know about coaxial cable, parallel line, transmission line, dielectric line, microstrip line, unbalanced line, or some examples of transmission lines are there. I'm just not going to that one. Just I'm starting with one circuit. Very interesting topic. And you will feel electrical and electronics and this type of basic electronics, you have read that one. That physical interference also you will get some glimpse from this transmission. Just simple circuit I'm doing. Simple circuit. Let's say point A and point B is there. In the book, it is not there. Please listen. Where from this transmission line is coming? Please mute. Whoever is. One second. Okay. Thank you. Let's say some voltage. This is a sinusoidal voltage. Let's say 230 volt, whatever. Some sinusoidal voltage we are giving. Let's say this type of voltage is there. And this is point A and this is point B. And already you know the current will flow from here to here. It will reach, let's say this is your load resistance RL. Just simple circuit I've drawn. And this length is capital L. Just let to know. This length we are taking a small segment of where we have taken A to B. So this voltage will go here, or the current, whatever you can say. Voltage drop leads to the current, right? So from A to B, it will travel. Very simple. And what the time?
Online class.
What you're saying?
Join the party.
Pradeep, are you saying anything?
Corona mask.
Look, what to say? This is called online. Okay, leave it. Just listen, everyone. Don't distract. So many disturbances are coming, I don't know why. So from A to B, what I am telling, the current is flowing, right? And let's say for traveling from this small distance, we are taking a delta amount of time. Delta, we can say this is a finite delay. This is a delay, or you can say this amount of time is taking to transfer this amount of current from here to here. Simple. Very simple. Now, look at this one. Look at the sinusoidal voltage. This is your peak voltage. This is your minus Vp, that you know. Or not peak voltage, you can say this is Vm, this is minus Vm. So your peak to peak is twice Vm, whatever may be. So look here, this point. In this point P, it has some voltage. Now the voltage drop is there. Look, I am arbitrarily taking another point Q. Another voltage is there. So this leads to a what? Potential difference. This leads to a some potential difference. Look, the voltage is fluctuating. So the current is flowing. That's why the voltage is fluctuating. It will create what? A potential difference. Potential difference. And another thing I told, look here, the current is flowing from here to here. So there will be some delay. That finite delay, we need to consider also. But so far, what you have read in basic electronics or electrical, we are not.
Last point.
Naveen, you are telling something?
Sir, can you repeat that potential difference point, sir, again?
Just I am telling, there are 2 points. One is the current is flowing from here to here. It should take some finite delay. And another I am telling, since I am taking one a sinusoidal voltage, so the voltage difference will be there. Here will be some zero, it will go increase, increase, increase. Another point, I am taking just a arbitrary point P, and another, the voltage drop will be there Q. If you take from P to Q, so there will be some potential difference. Why? Because some voltage fluctuation is there. So there are 2 types of things. First, you need to consider the delay. Another thing, since we are taking a sinusoidal voltage, not a DC one, so there will be a voltage fluctuation, which leads to a potential difference. But so far, in basic electrical or electronics, we didn't consider this one. Why? That is one important question. Why did we didn't consider this delay? Why we didn't consider all this potential difference and all? That leads to your introduction to the transmission line. Just I am telling here, we are considering one transmit time. We are introducing one parameter called transmit time. What is this transmit time? It is represented by TR. It is nothing but L by V. Now, what is this L? Or I am writing here only, that will be good. TR is your L by V. This L is nothing but this length. This V is the voltage. This V is the velocity of the wave, or you can say current, whatever may be. This, the velocity. It represents the velocity in which it is traveling from here, this point to this point. L is the total amount of length. Now, when we will consider this transmit time effect, when your capital T is greater than TR. What is your capital T? This is nothing but your time period. Very interesting thing. Time period. Already you know what is the time period. Just you draw one sinusoidal voltage. So this is your time period T. Now, if the time period is very, very greater than your TR, then we can ignore transmit time effect. We can ignore that. And so far, whatever you have read, we have ignored this effect because the time period what we are considering, it is very, very greater than this TR. Why? Look here, length and velocity. Look at this length. This length is very small, isn't it? Whenever you are doing some RLC circuit, RC circuit, whatever circuit you are doing, this length is what? In millimeter maybe. And this velocity is very high. So L by V is coming very, very less value. So that's why we ignore this term, transmit time effect. But if it is not so, then we have to consider. This lies to the introduction of transmission line. Just I am uh, doing some extra work. So we can write this is greater than
Sir,
TR L by
what
V.
is this? What is this time period, sir?
This time period is nothing but the time period for the sinusoidal wave. This is the sinusoidal I'm telling, na? Time period, you know. What is
Like
the
it
time?
has some value, like some it is some threshold, right? So it should have some value, like that.
Just I'm telling. Look here, you can consider any waves, right? 0 to pi, 2 pi. So your time period will be what? 2 pi only. So like that I'm telling. Understand? Whatever your time period is, I am writing in a generalized form. I'm not giving any values. In a generalized form, I am writing whatever waves we are taking. Look here, 230 volt maybe AC or 125 volt AC. So it will have some time period, right? That is predefined, whatever you are taking. But if it is greater than your this TR, means your length should be very small. Then you can ignore this transmit time effect. That I'm telling. Okay. So L by V.
Yes, sir.
So L by V is what? Acha, what is the relation between time period and frequency? 1 by F, you know. So this is nothing but L by V. Again, we can write V by F is greater than L. Can I write? Now, can you tell me what is V by F? This is nothing but what? Your lambda or wavelength. So this is the beautiful relation we are getting. This is called wavelength, you know. So what relation we got? If the wavelength of the signal is much, much greater than the physical length of the wire, we can ignore the transmit time effect. And that's we are doing. So far, we have studied all the circuits. We didn't consider this transmit time effect because the length is very small. But in transmission line, it is not the case. Why? Because we are dealing with a lumped loop, distributed circuit, where the length is very high, where the length is like that only. Length is very high. So we cannot ignore that one. We have to do the analysis of transmission line, including this transmission time effect. Now I'm just drawing another thing, just I'm telling. You know, maybe I'm just writing. If some capacitance is there, just I want to know. Let's say so many capacitors are there. These are capacitors, you know. What is XL? XL nothing but J omega L. I think you know. This is your inductors. And what it is called? This is called reactance. What type of reactance? Inductive reactance, you can say. Right? It is expressed in omega now, ohm, you know, and it is dependent on frequency, right? So if frequency is increasing, then what will happen? Your resistance will increase, right? Your resistance will increase. And inductance and capacitance are dependent on frequency. Just I'm telling, I think you know everyone. Resistance is not dependent on frequency, but your inductors, capacitors, they are dependent on the frequency. Xc also you know, 1 by j omega c. So obviously, if frequency increase, then Xc will decrease. That you know, right? Just I'm doing some revisions. I think you know all these things. Now, I just want to draw a distributed element or lumped loop. I think the course coordinator also started from that only. How to remember in the exams, that also I will tell. Just I'm drawing one inductance, one capacitance, then resistance, another conductance or 1 by n. Now, this is the basic structure. How to remember? This is a lumped loop, what I told. Why? Because we are taking this transmit time effect. So the length will be very high. And you have to don't have to remember all these things. These things should be repetitive. What I told, the length should be very high, na? So this you repeat up to infinity. It will go on like that. So first will be resistance. First will be your reactance, inductance L1. Second is capacitance. You can do it different way also. Just I'm telling, you know, some parameters are there, right? Resistance, inductance, capacitance. This is also a resistance, but we are writing in the form of 1 by R2. Why 1 by R2? It is in the form of a conductance. I think if you just remember KVL, KCL, then you can understood why this parallel resistance line we are writing in 1 by R2 form. Okay, so this thing we can write as G1. Okay, so L1, C1, R1, G1. So this in this way you just do repetitive. So second will be what? Again one inductance will come. Again one capacitor. Very easy. It is not so tough to draw the diagram. Again another resistance will come. Again one. This thing will be repetitive. So and so. Okay. I'm just not drawing the diagram. This will be what? L2. L1, L2. So this will be C2. Again, this one will be what? R2. This one will be G2. Like that, it will repeat. R, L, C, and G. These are called primary constants of the line. Please remember these things. Primary constants of transmission line. Why primary constants? Primary and secondary, you know. Primary means what are the primary constant? Means what are the elements or the basic elements which constitutes your transmission line. Look here, R, L, C, and G. These four are the elements only. So that's why it is called primary constants of the line. And in resistance, you will write in the form of resistance per unit length. So your unit will be always ohm per meter. Inductance will be what? Henry per meter. Please remember, just I'm telling. Capacitance will be farad per meter. And your conductance will be mho per meter. This you know, na? Mho. This is ohm. So this is your conductance. Huh? Please remember, whatever you are writing, it will be in the mho per meter. Per unit line. Because the length is very big. I am again repeating. This is your transmission line. The length is very big. So we are always expressing in terms of per meter. Whatever analysis we will be doing per meter only. Okay, I think it is clear. Very slowly I'm starting. I'm just not running. So if you don't understand also, you just please tell me. At any point of time, you can tell. Not an issue. Look here. And it is very interesting also. This is the entire length, we can say, big length. Maybe 10 meters or 20 meters line, transmission line, you know. Coaxial cables are very big, you know. Optical fibers are there. So many applications are there. Just I am concentrating a small portion. Let's say I am concentrating on this delta X portion. We cut the transmission line into two segments, and a small segment we are taking. A very small segment we are taking from this transmission line. Right. Now, just I am drawing this diagram. And again, I'm repeating, these things are nothing but this lumped loop only. Okay. So there will be resistance, again, inductance, capacitance, all these things will be there. I'm not drawing the diagram. Huh? Repeatedly, why I will draw. Just I am drawing this small segment line. How can I draw? Look here. First, what I told, inductance. Same thing. Inductance, capacitance. In this way, you remember. Next, what it is, resistance, conductance. This thing, correct? So, small segment I have taken where one resistance is there, one capacitance, one inductance, one conductance. Very simple. Now the current is flowing. Let's say I current is flowing. And this is your input V. And we are taking, let's say this is A and B. So let's say this is A point and this is B point. Very simple. Now, look here. Small segment we have taken. Huh? Can I write this is L into delta X? Why it is so? Because whatever we are writing in terms of per meter. So Henry per meter. So you have to multiply with this length. Because whatever we are writing, that is not the actual inductance. We are writing in terms of per meter. Right? In per meter, how many what is the inductance value and all. So if delta X length is there, you have to multiply with delta X. So capacitance is there, so we have to multiply with delta X. Very simple. R into delta X. This will be G into delta X. I think it is very simple. Now, here another current will come. Let's say this is I1, this is I2. And I'm writing this I2 is nothing but, or I can write IE only. One second. Writing I only, not telling I1. It has some reason. Just one notation. This is I. This I'm writing I dash is nothing but I plus delta. It may be plus or it may be minus. I'm writing delta I. So some current drop may be there, or this leads to some difference in current. It leads to some difference in current in point B. In point B. Correct. Similarly, voltage drop will be there. So if it is V, your V out will be what? V dash is nothing but V plus delta V in this side. So some potential drop will be also there at point B. This is nothing but your potential drop. Potential drop at point B. Correct. We can write this delta I as bypass current. Whatever current is bypassing, and delta V, we can write this is potential drop. Now, I am just drawing a relationship. How I can draw from these equations? How I can draw a relationship? Now, I'm going for the next thing. This delta V. Look here, we are concentrating on this delta V and delta I. Whatever voltage drop is there and whatever bypass current is there. Can I write this is minus of R into delta X plus J omega L delta X into I. Why? Already you know some relation. Voltage is nothing but R plus J omega L into I. Because the voltage is what? Current into resistance. This is nothing but XL. This is your resistance. So we are concentrating on just the resistance and the inductance. How we can write. So this is nothing but R plus J omega L. But here delta X is there, delta X is there. So I'm writing that one. And this minus sign represents some difference. Means if it is minus, then obviously it indicates that I2 is less than I1. This minus means I2 is less than I1. It can be opposite also. Just I am considering. Right? Similarly, delta I can I write as minus of G into delta X plus J omega C into delta X. Just a representation. I and V I am writing. That's why it is J omega C, not 1 by J omega C. If it is V and I, it will be 1 by J omega C. And G is nothing but 1 by R. How I am getting? Same thing. I is nothing but what? 1 by R plus 1 by J omega C. Like that. I'm just writing into V.
Sir, that should be 1 by no, sir.
Sorry, once again. This V should be like that.
In second equation.
V is nothing but like that. This into I. Right. So opposite thing, what we can write, I is nothing but, let's say this is 1 by R plus J omega C into V. Same
Okay,
thing
sir.
we are doing. Same thing. 1 by R is nothing but G, and this J omega C will come because reciprocal will be there. Correct. These two equations we have developed. Now, what we need to write? Limit. Just I'm telling delta X tends to 0. Because we know the definition of difference or differential d dx. Let's say this increment or this incremental distance is very less. So can I write del v by del I, sorry, del v by del x is nothing but dv dx. Correct? It is equals to what? Just you divide by delta x. It will be minus r plus j omega L into I. Similarly, we can write limit delta x tends to 0, del I by del x is nothing but, sorry, it is di by dx. Correct? It is nothing but g plus j omega c into v. I think it is very clear. We are just dividing that one and we are putting delta x tends to 0. It is coming dv dx and di. Now, just do one thing. Let's say this is equation 1. This is equation 2. You do another differentiation. What it will come? For equation 1 and 2. d2v dx2 is what? Minus r plus j omega L into di by dx. We can write. And we can place this equation over here, di dx. So it will be coming what? R plus j omega L into g plus j omega c into v. So we are getting an equation in the form of v. Here also v is there. Now you identify uniform plane wave equation. I think you can relate. What is the plane wave equation? d2v dx2 is nothing but again minus of some gamma is there and some voltage is there. So same equations we have derived, but in transmission line. Right? This is the equation, correct? So what we are getting? So we are getting an equation d2v dx2 is r plus j omega L. So how it is related, this transmission line, whatever equations you have so far done, it is almost similar. We can write this is also gamma square, right? So gamma square V, if you can recall that gamma square is almost similar to that one, what we have studied so far. So gamma square is what? R plus j omega L, G plus j omega C. And this gamma is nothing but the propagation constant. propagation constant. Similarly, we can write, if you can start, you will get, I am giving some home tasks. You can get these equations. You can get this equation. Okay. So up to this is clear or not, tell me everyone. Then again, you join the same link or not same link. I will give a different link because the recording will not come. Then we will solve this problem. Any confusion, you tell me. From where we have started the transmission line, right? Very slowly I'm doing. Finite delay. So delay is very less here. Length is very small. But in case of transmission line, the length is very large. So that we cannot ignore this transmit time delay. And we have taken a small type of
Sir.
Tell me.
Hello, sir. Can you hear me?
Yes.
Sir, can you go to the second page?
This one, na?
To the diagram, LCR circuit diagram. LCR circuit diagram.
This one.
Can you explain me why you wrote 1 by R2?
Just simple things. What I told, 4 parameters are there. One is inductance, one is capacitance, resistance, and conductance. Just I am writing in this form. You can, I understood why you are telling, because this is resistance, we can write in the form of resistance only. But you just remember that star and delta connections and all. So this is a representation. We are writing in the form of a conductance so that your equations will come easy for solving and all. Right? Because voltage, if you do KVL, so voltage is related to, if you do KVL and all, this R and some current will be coming, so you will be getting the voltage. But here, what? Current will be multiplied with this one. Sorry, voltage will be multiplied with this one, we will get the current. Like that. So just I am drawing a lumped loop where 4 parameters are there. So that's why I'm writing in the terms of 1 by R2. And this is nothing but your conductance, mho per meter. In this way, I am drawing. The parallel circuits are mho and series is resistance.